All right, welcome to section 2.4 on circles. Let's start off with the standard form of a circle. We talked about standard form for a linear equation. So most equations have a standard form. This is the standard form for a circle. X minus h squared plus y minus k squared equals r squared. All right, now typically when I give you an equation or a formula or something like that, I like to explain where it came from. Unfortunately, right now we don't have the background to really get into this with circles, but the book wants us to cover it, the department wants us to cover it, so we're going to go ahead and cover it. You'll just kind of have to take my word for it right now. We could go through and plot lots of points and you would see that this would actually form a circle. Or you can just take my word on it and we'll work through on how to use them for now. And then some of the form of this will make more sense later as we go through the semester and we talk more about graphing and stuff. Okay, so this is the standard form of a circle, and you're going to take my word on it for right now. All right, now this is where HK, okay, the H that is right here with the X and the K that's right here with the X, where HK is the center of the circle. And r, right here we're given r squared, r is the radius. So remember that a circle is defined by its center, and then all of the points that are on the circle are the equal distance of the radius from that center. Mine's a little bit lopsided, but you get the idea. All right. So HK is the center. We see that in the equation here. Anytime you have an equation or a formula where there's a minus in it, the number that you're taking out is going to be opposite sign. So H is going to be opposite sign of whatever's in the equation with the X, and K is going to be opposite sign of whatever is in the equation with the Y. R is the radius, but you're going to be given r squared, so you're going to need to take the square root. Now sometimes students get confused between square and square root. If you go the wrong direction, you're going to end up with a radius of something like 81 or 100. That's going to be silly, and you're not going to be able to graph it. So just remember, we're going to keep the numbers small and graphable here. So if you get a crazy radius, you probably squared it instead of taking the square root. Okay, looking at a couple of basic circles. Okay, if the center is at 0, 0, that means H is 0, Y is 0. We're just going to have x squared plus y squared equals r squared, because x minus 0 is just x and y minus 0 is just y. So it simplifies a little bit if you have zeros in there, you just get x squared and y squared. And then if we have center at 0, 0, let's say and with radius 1, that's called the unit circle. Okay, so centered at the origin with radius 1 is called the unit circle. And that looks like x squared plus y squared equals 1. So you may have seen the unit circle before, and you'll definitely see it again if you get into trig. That is one kind of special case of circles. But for the most part, we're going to look at ones that look a lot like the standard form. Okay, so let's look at an actual example here. Let's say that we have x plus 2 squared and y minus 1 squared equals 4. So if we want to find the center, remember it's going to be opposite signs. So it's going to be, let me highlight this. So opposite sign here and opposite sign here. So the center is going to be at -2 and +1. Okay, -2 and +1. And the radius, okay, remember this is being given to us as radius squared. So the radius is going to be square root of 4, which will be 2. Okay, so in order to graph this, we need to start at the center. The center is -2, +1. Let me get my graph set up a little bit here. Okay, so -2, +1. And then remember, we count, whatever the radius is, we count in each direction, because that's how far out the circle is going to lie from the center. So we can go 2 to the right, we can count that out. We can go 2 up, we can go 2 left, and we can go 2 down. And that gives us our circle. Okay, and I know it's hard to draw a perfect circle, just try to do the best you can. It should look reasonable. Okay, so that's how we take an equation in standard form and we get our center and radius and graph it. Okay, so let's say that we want to write the equation of a circle if it's got center 3, negative 2, and the radius is equal to 3. Okay, we want to write the equation of the circle now. So we know that it's x minus h squared plus y minus k squared equals r squared. Okay, we just had that on the last screen. We know that this is h, k, and r, so all you have to do is plug these in, okay? We're going to have x minus 3 squared plus y minus negative 2 squared equals r squared. And when we simplify, we're going to get x minus 3 squared. This is going to become negative, negative, remember, becomes positive. We get y plus 2 squared equals 9. Okay, so there's our equation with center 3, negative 2, and radius 3. So if you look at it, see our equation to our center, they're opposite signs. I've got 3, negative 3. I've got negative 2, positive 2. So if you plug them in, it'll work itself out. They will be opposite sign if you do it right. Okay, now the next thing we need to do is we need to talk about what happens if we're given an equation that's not in standard form. How do we get the center? Well, before we do that, let's do a little bit of a review about things that look like this, something squared. Okay, so let's say we have something like x plus a squared and x minus a squared. So when we multiply this out, remember you do x plus a times x plus a, you've got to FOIL this all out. What you end up with is x squared plus 2ax plus a squared. And when you FOIL this one out, the x minus a squared, you're going to get x squared minus 2ax plus a squared. Okay, so every single time when you multiply those out, that's what you're going to get. So for anytime you have something squared, it's always going to be in this form. So you're always going to have double that number in the middle, and you're always going to have that number squared at the end. And the sign here decides what the sign in the middle is going to be. The front and the last are always positive. So let's say that we have x plus 3 squared. Okay, you can always multiply that out, x plus 3 times x plus 3, and FOIL it all out. And what you should get is x squared plus 6x plus 9. Okay, so looking at these numbers, okay, we always have x in the front. We're not going to change that. So if you look, we've got 3 here, we've got double that in the middle, and we've got the square of that at the end. Okay, so whatever this number is, it's going to be double in the middle and square at the end. So working in the reverse, if we have, let's say, x squared plus 8x plus 16. All right, if we want to factor this, is this in the right form? Is this double a number in the middle and square of that number at the end? Yes, that number would be 4, right? Double 4 is 8. The square of 4 is 16, or you can think of it how you normally factor. What factors of 16 would add up to 8? X plus 4 times x plus 4, or x plus 4 squared. So we can kind of do a shortcut here in seeing the pattern, all right? Half of 8 is 4, the square root of 16 is 4, or going in the reverse from 3, double is 6, and the square of that is 9. All right. Let's look at a couple more over here. Okay, so let's say that we have x squared plus 2x plus 1. All right, is this in the right form? Okay, if I take half of this number, I get 1. And if I square it, I get 1. So if I take half of 2, I get 1. And if I square it, I get 1. So this should be x plus 1 squared. And it is. If you multiply it out, they're the same. So let's say we have x squared minus 6x plus 9. Okay, is this in the right form to factor something squared? Half of negative 6 would be negative 3. Half of negative 6 would be negative 3. Square that, and you would get positive 9. So this would factor as x minus 3 squared.